let's go ahead and do that. How many people here have actually heard about blockchain? Fantastic. How many of you, no, keep your hands up. Keep your hands up. How many people have actually worked with blockchain? Let the hands be up. Rest keeps your hand down. See, this is the state of affairs. Blockchain is something which is going to sweep away almost every domain, every industry, everything that you talk about in future. And that we are witnessing even now, and the pace will going to increase much more. And we need to equip ourselves on the blockchain technology sooner or later. There was a saying that what would have you done differently in the 95s when internet was launched, if you think about it today in hindsight. You might have done things differently if you think today. And that's because you might have created an email account in 98, 99 when the internet was launched in 95, 96, 2 years late. Today for blockchain, we are in the same situation. We are in the same era, what happened with the internet, we are in the same place for blockchain. And 2 years down the line, we'll think the same thing, just 2 years, not even 10 years, 15 years, 2 years that why didn't we get started with blockchain when Ritesh was talking at that point of time. 2 years down the line, you'll just think about it, just mark my words. Because that day in, day out, what I'm interacting with the people in the industry, with so many bodies and things like that, government, non-government, public, private, anybody that's talking about the next thing that's gonna happen in future, it's blockchain. No doubt. I'm not talking about cryptocurrencies. Cryptocurrencies might be, might not be, but blockchain is gonna stay, and that's gonna change the business model. That's how things are gonna work. So today, these two other topics we're gonna talk about, definitely you understand the icons. So one is machine learning, the other is blockchain. And we are gonna combine them together. That's the beauty, right? So we bring them together so that you try to figure out. So I'll give a small brief about what blockchain is so that most of the people who have not even worked on blockchain, they get an idea about what blockchain is all about. And then we give a small brief about what AI is, and then how do you bring together, what are the use cases, what you can do with these two things together. A bit about myself, I'm an architect, evangelist, and blah, blah, blah. But eventually, these are my contact. If you want to stay in contact with me, feel free to do so. I have written 5 books already. Some of the books are mentioned here. My book on blockchain is going to publish this month sometime soon, and will be coming out very, very soon. And in the beginning, there was machine learning. So we all know, 3-4 years, machine learning is getting a lot of prominence. Artificial intelligence getting a lot of prominence. And off late, we hear that then came the blockchain, right? Then came in the blockchain. We see a lot of activity around blockchain these days. There's a lot of hype around these technologies, right? Everybody, AI, ML, hype, blockchain, hype. So why not combine them and create much bigger hype, right? Is it really a hype? The truth is that this is not a hype. It's not a hype, and converging these two technologies can really bring in new paradigms in the way you're making solutions today for your customers, for your employees, for your partners, and things like that. It's gonna change the way the business models work. How many people here sitting, just give me an example, just tell me, how many people sitting here actually bought a music CD in last 2 years? Just raise your hand. Not a single person has bought a CD in last 2 years, a music CD. Why do you think you have not bought a music CD? Because the way music industry has changed over a period of time. In the 90s, there was no other alternative. You had to buy a music CD. At that time, there was no CD, but there was floppy and other media. But you had to buy. There was no other choice. And at that point of time, if I would have asked you, how many people bought music? Everybody would have raised their hands that I bought music. Why do you think we don't buy music? What happened in the 90s that bring about this change? Anybody? Torrent? No, torrent was not there at that point, right? No, it was not. I like the answer, but it was not there, sorry. No, it was not even MP3. There was a company called Napster, which launched a peer-to-peer protocol. It's not torrent. Which launched a peer-to-peer network for the first time in our history of computing, and which really changed the way music industry works. How it used to work before Napster was that there was a composer who used to come and who used to compose music, and there was a distributor in center and who was supposed to market and do the distribution of the music. This guy was solely responsible, who knows both the consumer and the composer. Composer does not know about the people who are hearing the music, and the people who are hearing the music, though they know who is composing it, they were not indirectly in touch with each other, right? It's the middleman in the center which was actually making the big money as well and was directly in coordination with these two. When peer-to-peer network got launched, the composer got in directly touch with the music listeners, and the music listeners got directly touch with the composer, and this guy who was making maybe 20% at that point of time started making 100%. He was no more giving that big fat revenue to the music distributor and marketing companies, right? That's a big shift. So wherever you can have the possibility of a peer-to-peer network coming in into any business model, that business model is bound to get disrupted. It is bound to, because every business model has intermediaries in between, which are commissions, earning a lot of commissions. You think about banks, you think about insurance, what are they? When you do a transfer of money from one location to another, from one country to another, how much time it takes, first of all, how much commission they charge, you are not even aware of today, right? That's the big possibility of blockchain bringing things into picture. But peer-to-peer network is not blockchain. Peer-to-peer network, when you integrate integrity to it and bring trust to it, where you can rely on the parties who are doing transactions. You can't rely transactions on a torrent. You can't do on a peer-to-peer network. But when you bring these two factors into any peer-to-peer network, you are getting into the blockchain world. That's how you get started. I'm making it very crisp for you to make you understand because of there's a lot of things to discuss. So just try to take this, that when you have integrity and trust within peer-to-peer network, where people on the network are trusting each other, the nodes, there is no central agency, everything is decentralized. Nobody controls anything, everybody controls everything, kind of a situation, pure democracy, you're getting into the blockchain world. And blockchain, you store data into a ledger. What is a ledger? Ledger is a place where you go to your bank, for example, yesterday, you went to your bank, you deposited 100 rupees. Today you go to your bank and say, make it 50 rupees. Will the bank do it for you? It will not do it for you. Come on, it will not do it for you. How many people say it will do it for me? Right? It will not do it for you. Say, if you really want to make it 50 bucks, do a new transaction, right? I can't touch the old transaction. That's the way it works. That's the property of a ledger. It is immutable in nature. You cannot change a ledger. If you really want to affect change in a ledger, you need to bring new transactions to affect that change. So data, the transactions that you do on blockchain between multiple parties on a node, actually gets stored onto a ledger, which is append-only, immutable in nature. And that ledger, if there are 100 participants, is actually getting replicated across every participant because it's a peer-to-peer network. And so everybody has a source of truth with them, that this is what has happened in terms of transaction, this is the current state, this is the balance this guy has, this is the balance that guy has, and that's been maintained by everyone. That's what, in short, blockchain is, right? So I've covered these things. It's a distributed database. When I say ledger, you're storing data. What is a data store? So it's a database, might be a strong word. You can say it's a data store, right? What do you do with AI? You need a lot of data. That's where the convergence starts happening. But we'll come more into that. So it's a network of large number of nodes. It's a lot of people interacting who has a copy of that ledger and who maintains that data and also ensures that any transaction that happens still gets replicated across the network so that everybody has the same source of truth. Nobody is lacking behind. Now, how do you bring integrity and trust into this? I talked about bringing integrity and trust within the peer-to-peer networks. How do you bring that? Using cryptography, using symmetric, asymmetric encryptions. How many people are not aware of this? Give me a shout, come on. Okay, only one. So I'm not going in much more detail into this, but you understand what hashing is. It's a one-way movement of data so that you cannot recognize what the input data was. So you give an input to a hash, it will give you an output. The uniqueness of a hash is that it is always the fixed number of characters within the string. Neither more, neither less. If I give just one word, it will give me 256 characters for SHA-256 algorithm. If I give the entire book, entire universe, all the text on the earth, then also it will give me 256 character only. And the possibility of collision is very less. That's the beauty of it. So we store everything in this ledger using hashes. So whatever transaction happened, A give B 200 rupees, we hash that transaction. You get a fixed amount of data. You put that data into blockchain, into that ledger. You don't put A, B, and things like that. But you maintain balance separately that A has 100 rupees, B has 200 rupees. So with that information, the transaction stored in hash, and with the balances or the state being managed separately, that's how you do blockchain. There's a concept of smart contracts through the help of which you can extend blockchain. Now, blockchain comes as a platform. You have a platform with you. What good it is for me if I'm in a transportation business? No good for me unless I can store transactions related to my transportation. So blockchain helps you extend and write logic for your transportation, for your logistics, healthcare, for your something else, whatever it is, using smart contracts. That's the way you write your logic within blockchain so that two people can do transactions using your smart contracts based on the logic that you have coded over there. I hope everybody is with me. Anybody not with me? Fantastic. We just saw hashing. How are transactions stored? Transactions are stored in blocks, and blocks are stored on ledger, and these blocks are chained together, and that is why it's called blockchain. Right? Not going in more details here, but there is much more to go. I'm talking at 30,000 feet right now. So this is how, these are the nodes I was just talking about. A transaction comes, it goes, hits one of the nodes. The data gets written onto one of the ledgers, and one of the nodes then gets replicated across all the nodes in their ledgers. So Sam wants to send dollars to Mark, transaction reaches the network. The nodes compete and validate the transaction, which is a process. So who writes a transaction in a bank? Who writes in a bank your transaction into a ledger? Whose job is it? Accountant. Somebody said accountant. It's a job of an accountant. It's a clerk. That's what is a job of a miner in a blockchain world. A miner is an accountant or a clerk whose job is to write data into ledger. That's all. You cannot edit data, obviously. You cannot delete data. You can only modify, you can only add data. So that's the job of a miner. So they compete among each other to write who will write first. If there are 100 nodes and I give a data and say everybody can write, then your ledger will get corrupt. It's only one person at a time can write. So they compete on some consideration. Once we decide that this guy is the winner, he writes it, and then this guy replicates it across to the network. That's how it, on a very high level, works on blockchain. Some of the major blockchains are Bitcoins, Ethereum, Hyperledger. You might have heard of it. Bitcoin is different than blockchain. Bitcoin is, the underlying technology of Bitcoin is blockchain. Just be aware of that. So it's a matter of trust, which is normally missing in a transaction. I buy a car from you. I give you a check. What is the possibility the check has money into it? There's no guarantee. So that is what is missing in any transaction, right? So if you're buying a house, what is the guarantee the house title belongs to you, right? Blockchain is trying to solve that problem. It's that this is a currency, this is your digital asset. You give me that and I give you the money as an atomic transaction at the same point of time. There's no lag. Give one hand, take one hand at the same moment, and that's what smart contracts let me do that. There is no need for an intermediary, because even if you do an intermediary, you give money to him, you give your home to him, he might run away. There's still possibility of no trust. But with smart contracts, when you do atomic transactions, you give me, I give you, either it's any currency or it's any asset, then you are getting into the blockchain thing, so on smart contracts. That's how smart contracts actually work. These slides will be available, obviously you go through it, and if you have any queries or if you want to have some questions, feel free to ping me on my social links that I provided earlier. And what is machine learning? We all know machine learning, so I'm not going deeper into it. Machine learning will transform the world too, but you do some of the most important things with machine learning, like image recognition, text mining, NLPs, anomalies, fraud detection, sentiment analysis, and you are driving your cars nowadays with that and things like that, driving robots with that and things like that. But you need data for that, right? You need big data for that. Without data, machine learning cannot do things, wonders that is what we see today. You need a lot of data. You need training data, you need testing data. When you're doing supervised, when you're trying to find patterns, still you need data. And that's big data is needed for making sure that your AI can be successful, your machine learning can be successful. And some of the characteristics are typically three V's, which are volume, variety, and velocity. So we do all of these things in machine learning. Now, how do we bring these two things together is what we are gonna see. So there are two ways to bring. So think about that ledger on blockchain is as a data source, right? You can think about that. It's my data. I can get easily all the transactions. If millions of transactions are happening on my blockchain, I can read all of that data, bring that data, and do some machine learning on the top of it, AI on top of it. But what is the beauty of that data? The beauty of that data is that it is a genuine data. There is no anomaly in that data. There is no such data which says that A gave money to B, but that transaction never happened. It's a forged transaction. There is no possibility because when you do blockchain, when you write into a ledger, it's been validated by all the people who are part of the network because that data is available to everyone, right? So as part of mining, when somebody writes it in a ledger and says, okay, I've written to the ledger, please accept my new data, they all will verify whether this transaction is actually happened or not. While if this is even one of them says it did not happen, the transaction will not be written to the ledger. So it's a good data that you get. Normally, you don't get good data when you do AI because you need to do a lot of ETL, you need to do a lot of parsing, grouping, enriching. You don't need to do any of those things with the data that's in blockchain because it's a good data anyways you're getting. And since I talked about blockchain data being available across industries, you can put AI, bring AI level insights, machine learning insights into across industries. For example, I might be trying to predict the price of a car based on the transaction that happened on the purchases of different kind of cars. I can use the machine learning on the data of transaction that happens with the car. I have some few more examples, but there are two modes in primarily you can use the data that's there in blockchain. One is the batch mode, that you read all the data of the last one's transaction and do some processing on top of it. In that case, how you would do it? Typically, you will come to, so this is the overall architecture. So what you do is you have a browser, you have an API layer, you have something called Web3, which is the way you talk to blockchain. You write into these nodes. This is nothing but peer-to-peer network. And you have some timer job which takes that data, put into a data store, and do some machine learning onto it, right? So that's an overall architecture you can follow in a batch mode. In a real-time mode, it's more about streaming. You are not looking at batch, but you're looking at the data as it comes in. So instead of first writing into blockchain, somebody is trying to do a transaction. Say, for example, in this case, for example, I am sending an image, and I want to extract text out of it. I'm making a messaging application. So instead of sending text, right, I'm uploading an image, so that message should go to anybody who is interested in that image. But how do I find who is interested in that image? It's based on tags. So I can send that image to a machine learning algorithm, get classification, and get some tags out of it, right? Once I get the tags, I can read all the users who are interested in those tags and send that email, send that image to only those people who are interested in those tags. Now that I can do in a real time. I don't need to do in a batch mode. And that's what it shows, that I send it to a cognitive service gives me tags, I take that image and tags, go to the Web3, I store that into my ledgers, the image hash and the tags, and then I send those data to all the people who are interested into that particular image. So that's just upload an image and only people who are interested in those images can get that image directly using machine learning. So that's a real-time usage of machine learning. You can obviously create better AI models instead of having in silos data. Since the ledger is one source of truth for everyone, you get better prediction, you can get better classification rather than all in silos sample, because you get the entire population. You're no more playing with sample. Typically you play in sample with data, right? But with the blockchain, you have the entire ledger. Everybody has the entire data with everyone, right? Every node has the entire ledger. So it means every node has the entire data with them. So you can always read the data. Any node can read all the data and create some machine learning and execute a machine learning algorithm on top of it to do whatever activity they're trying to do, whether it's a fraud detection, whether it's a anomaly detection, whether it's a sentiment analysis, or things like that. Right? And it's also qualitatively good data. There is no anomaly in that. So you can always be sure that there is no bias, there is no untoward data which might skew your data and things like that. So statistically, this data should be good. Some of the use cases that we have seen already by blockchain and AI coming together, fraud analytics. Typically, blockchain data is related to transactions or transfer of virtual assets or assets, digital assets between people. So you can do real-time fraud detection on the data, because any deviation, because the data pattern will almost remain the same, any deviation on the data pattern you can quickly capture, because they will be far and few, and can do fraud detection based on the blockchain data and using machine learning algorithms. This is the same architecture I was talking about, that somebody user once sends an image, you can send to a classification, get all the tags, and then using smart contracts, store it into blockchain, and then send to everybody who is interested in that particular image. So if you heard about Steammate, if you heard about decentralized messaging platforms, they all do all of these things today. Some of the other use cases that you can think about are stock market price predictions. You can do sentiment analysis. You can do supply chain counterfeiting. For example, how many people eat fish here? Oh, very few. Forget it. Rolex. How many people you think they buy Rolex and they think it's a genuine Rolex? It's very difficult. It's very difficult to figure out. So what I can do is, when a Rolex is getting manufactured in Switzerland, I can exactly find out which factory it got manufactured, by whom it got manufactured, at what temperature it got manufactured, at what humidity it got packed, and things like that store into blockchain. And from there, what was the packing condition, I can put on blockchain. From there, it went to which store, which warehouse it went, I can put that onto blockchain. What was the latitude, longitude, I can put that. From there, it went to which distributor. From there, it went to which country, how did it shipped to India, how did it come to our distributor, how did it come to the retail shop, or what, and all the various parameters that affects a watch, I can store all that into blockchain. And then if somebody is buying that watch, there might be a scan code on top of it, barcode on top of it, I can just scan that, and all of the information from the starting till now, I can read that onto my mobile phone. And I can predict I can know whether it's a right watch or not, it's an authentic watch or not. That's the kind of beauty you can build on top of blockchain. Now, if you store all of those data for all the watches on the blockchain, you can run machine learning algorithms and see how effective your watch has been moving, from which, what was the defect rate, for which temperature, for which factory, for which country, and do some AI machine learning stuff and predict how you can make your entire model better. Just an example. Thank you. I have just 2 minutes left, so any questions, feel free to ask me. More than happy to take them. Yes? How? Okay. So there are multiple factors to it. How green? The question is how green the blockchain is. So there are some algorithms which makes it non-green, but there are other algorithms in blockchain which makes it very green. So there is a yes and no to it. So proof of work makes it non-green. But if you think about proof of authority consensus mechanism, proof of stake consensus mechanism, it is very green.
How secure is the blockchain data? How secure is the blockchain data?
So how secure is the blockchain data? So normally anything on the blockchain which is on the public domain, anybody can go and read it, but you can create a private blockchain as well, and it's completely secure. More secure than in normal centralized application that you create.
Write the transactions.
Competes, yes,
Yeah,
competes.
why do they have to compete?
So one of the consensus algorithm, no, I'll discuss this separately. I'll go more deeper into it. Yeah.
So few industries have their traditional way of keeping data. If they want to move to blockchain, how the process happens?
So you mean if they already have data now, they have to move the data?
But
so
they need to move to blockchain. They need to change the complete process.
No, so they will not move those transactions as is. They can move the state. That the current state is, based on these transactions, my balance in this account is this much in money, I have this asset. They can move those assets, and then from there on, any transaction that affects those assets, they can do in blockchain.
So I'm a software tester, and if I had to test blockchain,
you are in big trouble, man. Not big trouble, you have the biggest responsibility, that's what I mean to say, because blockchain is a new paradigm. There are a lot of ways people are trying to hack it, as you mentioned how secure it is. And so testing will play an equal amount of work as a development. It's like 50-50. That's why it's very important that every aspect of blockchain applications are tested to the extent of not only performance tests and things like that, but security tests to a large extent. So it's very important.
Any pointers to get started in
We-
testing?
We'll just discuss this. This is a specific thing on testing, so we'll discuss this.
When you gave example of using AI, you gave many examples wherein, for example, in industry and logistics and all. So, like, anyways, they have that data with themselves, and considering private blockchains, they are not going to share their private information with other parties involved. So, like, they currently have all those information already on their servers, right? So they can do machine learning there and there itself, right?
The thing they don't have today is immutable. If they want, they can manipulate. With the blockchain data, they cannot do manipulation. Second is that this data, which is immutable, which they cannot manipulate, is also validated by all the miners. It's validated by all the nodes. So there is no possibility of fraud happening over there, which is not possible in a decentralized application.
But the thing is, the information which they are going to use for their algorithms is the same information that they already had. For example, considering the logistic point of view, if there is like some shipping related firm, that will have whatever detail that it's, whatever
The data will
information-
remain same, but they cannot. So, for example, if Nirav Modi, what did he do? They have the data in the home, but had it been blockchain, which integrated with all the systems, this might not have been possible.
Right, but okay, I get your point regarding the bank transaction which took place, right?
So it's the data. It's eventually the data. Even my Rolex, I can have a fake Rolex to start with in my factory, correct?
Right.
And I will never let my data go into my blockchain at all.
Got your point.
Yeah, two more questions. Yes.
So my question is related to blockchain infrastructure. So I see in the world there will be, if you see infrastructure like you given the example of Rolex. So there will be some, you told that Rolex manufacturing will happen and then you have some tagging that you can know the temperature, everything. So there will be one infrastructure for the Rolex, or you told a watch. Similar way in the world I can see so many infrastructure will be there. So I don't see anything global infrastructure which will take care of everything.
No, there are global infrastructure available. For example, Ethereum infrastructure is global.
This is the platform where you will make the as per your need actually, right? For Rolex will make it.
So based on your need, you write your smart contract and deploy it to the global environment.
Yeah. So as a user, I will be needing the this watch, mobile, n number of things.
Whatever you
so
want.
I have to be part of, for everything. I have to be part of that infrastructure to get the trust information from
Yes.
that.
Yes.
Is it-
You
is
just
it too much
you just need to be a client. That's all. Like a
So,
browser.
Is it like this is the way it happens? There is no something like single place where we can get trust.
See, you have both the options. They can be single. You can have your private. You can have multiple nodes. The choice is yours. If you don't want to share data with somebody else, keep it private. If you can share the data, do it public. So the choice is yours.
Okay,
Right? So thank you very much for your time.
One question. Sorry.
One last
That was-
question. Yeah.
Where was that? Oh, okay.
So Aadhaar card could be the,
Oh, absolutely. Yes, yes.
and like universities can give
Absolutely.
degrees.
All your degrees can be over there. And when you apply for a job, you can always say, please refer to this. And you don't need to send those certificates. They can validate directly.
That's the point.
Yes.
So Aadhaar card is still not on the blockchain?
Aadhaar card there's some plans going on actually, I think,
Okay.
of Aadhaar card moving on to the blockchain as well.
Thank you.
Thank you
Please,
very much.
please be